Hello, in this video I will briefly explain the solution of the problem named Daniel Bernoulli and Petersburg problem 1938. Firstly, let's take a look at the context of the problem. So this is our problem, and now let's see its solution. If all previous n-1 numbers of throws are tails and the nth throw is a head, then the player wins on the nth throw. The probability of this process is 1 over 2 to the power of n, and then the player is paid 2 to the power of n minus $1. Therefore, the casino will pay the amount calculated from this formula. From this formula, we can see that it doesn't matter how large amount of money is initially paid by the player to the casino, or the player will always finish with profit. Theoretically, the game will be fair only if the player initially pays infinitely large sum. Now let's continue with the discussion of this problem and the perspectives of different mathematicians on this problem. This problem has been one of the most discussed problems through the history of probability and statistics. Firstly, this problem was proposed by Nicolas Bernoulli in the letter to Pierre Raymond to the Montmartre in 1913. The problem was then taken up again by Daniel Bernoulli, who is shown in the picture, and published in a similar form to the problem 11 in the Petersburg Academy Proceedings in 1938. The problem is also known as Petersburg's paradox. What is paradoxical about the problem? It's the solution that the player should pay infinite amount of money to the casino. Let's calculate the probability of winning within 3, then 4, and then 5 tosses. We can see that the probability of winning within 3 tosses is 0.875, within 4 is 0.938, and within 5 is 0.969. From this calculation, we obviously see that the player can win within 5 tosses, and in this case, casino will give $16 for that. If casino gives $16 and player has given infinitely large amount of money, then from my point of view, it's not a fair game. As I mentioned before, there have been many mathematicians who discussed this problem, and I will talk about a few of them briefly. First of all, according to the Allenberg, there exist two types of probabilities, which are metaphysical and physical probabilities. For him, an event is metaphysically possible if its probability is mathematically greater than zero. On the other hand, an event is physically possible if it's not so rare that probability is very close to zero. Thus, Allenberg believes that very small probabilities ought to be treated as zero. Although Allenberg does not explicitly give a cutoff probability to decide when a metaphysically possible event becomes physically impossible, he gives an example of a coin that is tossed 100 times to illustrate the notion of physical impossibility. Therefore, let's take p less or equal 1 over 2 to the power of 100 and solve the problem. Here we get a result that the player should pay $49.5 to the casino. Great naturalist Buffon solved the problem in this way. However, he took probability less than 10,000, and here the result is $6.5. Several mathematicians such as Condorcet, Poisson, and Catalan argued that there is no casino that can give infinite amount of money, and the solution is on the screen. We can see that the player should pay n over 2 plus 1 amount of money to the casino. Additionally, Gabriel Grammer and Daniel Bernoulli both favored favored a solution that involves to the concept of mean utility and moral exceptions. Suppose a player has an initial fortune x0 and has a probability pj for j equal to 1 to the k of winning an amount ag where the sum of pg is 1. If at any stage the player's fortune changes for the x to x plus the x, then Bernoulli suggests that the change in the player's utility u for the fortune is the u is proportional to the x over x. This means that for a given chance in the player's fortune, the more money the player has, the less will the change in utility be. For the u is proportional to the x over x, we get u equal to k ln x plus c, where k and c are both constants. And the mean of player's final fortune is shown on the screen. Then, if we consider that player has initial fortune x0 and initial payment for a pair game, Bernoulli sets the player's mean utility for final fortune to be 0. The equations shown on the screen can be solved when the value of x0 is specified. Finally, it's worthwhile reconsidering the original Petersburg game with one modification. If a head appears first on the nth toss, then assume the casino pays the player an amount of s to the power of n minus $1, where s is greater than 0 and less than 2. For the game to be fair, the player should pay 1 over 2 minus s dollars to the casino. To conclude, I tried to show as many solutions as I can from different mathematicians, and from my point of view the most appealing one was Daniel Bernoulli's solutions because of having concepts and better, deeper explanation. See you, thank you for watching.